Hey, welcome. Today we're going to learn how to solve triangles that don't have a right angle in them by learning about the law of sines. The law of sines is a proportion that is true for all triangles, not just right triangles. And it is simply that the sine of an angle divided by its opposite side, so sine of A divided by A, or sine of B divided by side B, and so forth, that set of fractions is always equal to each other for a given triangle. What we can do is, if we know like 2 out of the 3 sides or angles or so forth, we can put in the things that we know and solve for the piece that we don't know. Now, in a future video, we'll learn about another fact called the law of cosines, which is true for all triangles. In general, when we're solving triangles that aren't right angles, those types of problems can be divided up into a handful of different categories depending on what types of things you know. For instance, if you know, say, 2 angles and one side, angle, side. Notice here I know this angle and this angle and this side, for instance. You can solve for everything else in this triangle by using the law of sines. Alternatively, if you know, say, one angle and then a side and then the next angle, you can also solve this sort of triangle using the law of sines. If you know 2 sides and the angle that's opposite them, you have to put it in this way, side, angle, because otherwise it's kind of a naughty word. But if you know side, angle like this is also one that you can solve using the law of sines, but it has a weird twist in it. Sometimes it's called the ambiguous case, and I have a separate video specifically dealing with that situation. The other two, if you know all 3 sides but none of the angles, you can use the law of sines, but you'll also need to use the law of cosines to help you with that one. And if you know one side and then an angle and then the next side, that also is a situation that you need both the law of sines and the law of cosines for. So let's see that equation at work in an example. Here's a question familiar to us: solve the triangle. But what's different about this triangle is it is not a right triangle. So as we look at all the different facts that we've learned about triangles so far, the Pythagorean theorem, that doesn't really apply. It doesn't work for a non-right triangle. These trig equations here, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and so forth. Those don't work if we don't have a hypotenuse. This isn't a right triangle. Can't use it. This equation is true. All triangles have their angles add up to 180. And the law of sines is also true, because that's true for any triangle. So those are the equations we'll have to work with today. Let's organize our work in a table like we've done before. And so I know that angle B is 28 degrees. I know angle C is 103. I know side B is given to us as 26 units long. And maybe I'd take a moment and see if we can find angle A. We can use the angle sum theorem for that. If we have all 3 angles and we put in the angles that we know, we can subtract 28 and 103 from both sides, and we get that angle A is equal to 49 degrees. And so I can fill that in a moment. But it's going to be a little bit more work to figure out one of these sides. In order to do that, we need the law of sines. So let me pull out the law of sines. Remember, this says sine of angle A over side A is equal to sine of angle B over side B, and so on. And so if we start filling in what we know here, we just figured out that angle A is 49 degrees. And side A we still don't know yet, so I'll call that A. Angle B was 28 degrees, and side B is 26 units long. Angle C is 103 degrees, and side C is unknown. And if we look at this equation, we've got a bunch of different fractions all equal to each other. If we look at a certain combination of those, say the first two here, that's a proportion. We can solve a proportion by cross-multiplying, and especially this proportion, it only has one variable in it. So we'd be able to figure out what a is if we did that. We could also look at this combination of fractions, and again, we have a proportion. The one piece that we don't know in it is angle C. It's even possible to look at the outside equations and set them equal to each other. In this case, that wouldn't be helpful because there would be two variables, but sometimes that's useful. So let's look at that first combination again and write an equation. Remember, we solve it by cross-multiplying, so a times the sine of 28 is going to be equal to 26 times the sine of 49. And sine of 28, sine of 49, those are really just numbers in fancy lettering. And so we could divide both sides by sine of 28, and we could figure out what a is. A is whatever this 26 times the sine of 49 divided by sine of 28 is. So if you type that into your calculator, 26 sine of 49 divided by sine of 28, I got that a is about 41.8. And so we can fill that in, 41.8. And if we want to find side C, normally, with knowing 2 out of the 3 sides, I'd be reaching for the Pythagorean theorem, but I can't. That doesn't apply in this triangle. And so you're going to have to set up another fraction like this time using this combination of sides. So since C times sine of 28 has to equal 26 times sine of 103, I can now divide both sides of this equation by sine of 28, and we'll get that C is 26 sine of 103 divided by sine of 28. And if we get out a calculator and type that in, we get that our third side here is 53.9 units long. Once again, when you have your table filled out like this, it's a good idea to check that your smallest side is across from your smallest angle, the middle side is across from the middle angle, and the largest side is across from my largest angle. All right, so now it's your turn. Here's another triangle that you can try to solve. I would encourage you to pause the video and see if you can work it all out, or you can continue to watch and see how I did it. First thing I notice is that I know 2 out of the 3 angles, and so I pulled out the angle sum theorem and figured out that the missing angle here was 26 degrees. The next thing I did was use the law of sines and filled in as much as I could. So I knew that angle A was 26 degrees. I knew angle B and angle C. I knew side C that was here. And then the key step to figuring out the sides that we don't know is to set up some proportions. So if you look at this first fraction and this last fraction, you can set up a proportion that A times the sine of 118 is equal to 14 times the sine of 26. You can do a little bit of solving and figure out that side A is about 6.95. Then if you look at the middle fraction and the last fraction, you can set up a proportion there that B times the sine of 118 is equal to 14 times the sine of 36. And then a little bit of arithmetic gives you that side B is 9.31. So putting all that together, we've got our final answer here, all the different sides and angles. And again, quick check, the smallest angle is opposite the smallest side. The middle angle and middle side are opposite, and the biggest angle is opposite the biggest side. So there is our video on solving general triangles using the law of sines, but that's not the end of the story. Definitely come back for the next video where we learn about a special type of triangle that has, well, let's just say it's kind of weird. So we'll see you then.